Our discussion today, we will discuss deeply in the how the Apache Spark work for supporting the big data environments. You already know that we have a lot of components in the big data environment that will be work with the coordination for support the big data computational or big data process purpose. So Apache Spark is one of the essential component in the big data environment, also with another component that work together with Apache Spark. And we will discuss today about this tools and what is the function, how it's work, and what is the computation side of the Apache Spark. So in the future, hopefully, the purpose of this explanation is to give you some knowledge and also give you some right position when you see the Apache Spark as big data tools. So of course, if you have any question, you can state your question in the chat facilities, or maybe you can speak up with your microphone. Okay. Okay. So I would like to share the material. So the Apache Spark actually is one of the product family of the Apache. Yeah. So if you're looking for in the website in the internet, you just state the Apache Spark. So you will find the Apache Spark called is Unified Analytic Engine for Big Data. So yeah, this is the Apache Spark. Yeah, he claimed as lightning fast and unified analytic engine. So yeah, the most advanced of the advantage of the Spark is yeah, he's lightning. So he's not very heavy for running for a big data. And not heavy, it's mean when he run by itself, it's not heavy. Of course, it will be based on the how much the data that will be in the process of the Apache Spark. And fast, yeah, because this is more faster than several approach, yeah, another approach or another methods, yeah. And even based when compared compare with the Hadoop, Spark is more aggressive, yes. So somehow today mostly in the industry they for several type of data they prefer to use Spark than Hadoop, yeah, because yeah this advantage the fast and then the lightning unified analytic engines. So when you see here, the Apache Spark is the place is like Hadoop actually. He is like it is like side by side with the Hadoop, yeah, or head to head with Hadoop. So these two kind of engine actually have same function in big data as a main big data file system for analytics process, yeah. But the difference is, of course, based on the uniqueness of the data that will be processed in the analytic engine, and also the benefit that we want to gather from the each of the engine. Yeah, you can access this one spark.apache.org. Actually, a lot of information that you can use. And beside that, also the Apache Spark can be worked side by side with Hadoop. Yeah, so yeah, actually it's because same family in the Apache, the Apache environment. So the compatibility between the engine actually is there is no big deal in here. Yeah. Okay, so let's discuss with this slide. Okay. So when we discuss about the Apache Spark, actually, what is the Apache Spark itself? Yeah. So we can learn from the main concern on the main focus of the Apache Spark itself. Yeah, Spark SQL actually. Yeah, this is the relational system actually are popular. Yeah, but unfortunately is insufficient for big data application. Yeah, because the SQL itself is the condition is like procedural, yeah, and then we need to follow some procedure that we want to run as SQL. So that's why is sometimes is insufficient. Why is insufficient? Because in big data, the environment is very extreme, yeah, very extreme. And then it's because we deal with the very variative data, the velocity and the veracity is very different, and so that's why it's very not yeah, it's not very matched with the relational system. And somehow user want to perform the ETL, yeah, extract, transform, and load to and from various data sources. But somehow they will face head to head with the structure of the data. Somehow it can be that the data source is in the form of semi-structure, somehow it's unstructured. So that's why we need require a custom code that will maybe it became more, more difficult to implement in the SQL. So and user want to perform advanced analytics, yeah, not only just statistical based analytics, yeah, like sum, mean, or another things, but yeah, like us in computer science, we need to run a machine learning, web processing, and etc. Somehow we work with the artificial intelligence and so on. So based on this need, of course, we need the sufficient environment to implement the algorithms. And then also the challenging to express in the relational system is still exists, yeah. So that's why it's very, it will be the concern of this approach, yeah. And then we also have the challenge that most data pipeline are a combination of relational queries and complex procedural algorithm. So for example, in the operational, the algorithm that we use in the big data processing somehow is not only just linear algorithms, but we need to hybrid several algorithm into one processes, and somehow will be like, combine each other to gather the better accuracy, to gather more precise, and then to have a good and then appropriate level of the quality of the data. So the Spark, the idea of Spark SQL is how we combine both model in the Spark SQL, yeah, that provide DataFrame API, of course, and then using the extensible optimizers, yeah. After this slide, I will give you some information. What is the structure of the Spark SQL? Yeah. In the DataFrame API, we can perform relational operation that normally we run in the normal way, yeah. And then on external data sources and built-in distributed collection, and also is using the data frame concept that similar in the R, yeah. If you have experience using the R application, I think you will understand about the concept of data frame, yeah. So the Spark SQL actually is run as library on top of Spark, yeah. So of course you still understand that Spark is the layer that work like same like HDFS, yeah. The Spark is giving the environment to run big data processing, yeah. So that's why in the Spark we call the resilient distributed data set, yeah. And then the Spark will be communicate and then will be connected, or maybe will be operate with the sorry, okay, with the some of the several exposed in the SQL interfaces using somehow GDBC console, or maybe using a familiar program like Python and etc. And then we have a Spark SQL with DataFrame and Catalyst Optimizer to working on with Spark. Even we cannot use this DataFrame and Catalyst Optimizer directly if we have like program in Java or Scala or Python directly work with the Spark. So this is will be Spark itself as engine. It can serve the Spark SQL with DataFrame and Catalyst Optimizer, or directly with the common program like Java, Scala, or Python. Yeah. So what is a DataFrame API? Because this is the main component on the Spark SQL. Okay, in the data frame, it actually is a distributed collection of row with the same scheme. Yeah, so it's mean like we we bring a table or we bring collection racks or something. Yeah, it's somehow equivalent to a table in a relational database. Yeah, but in the distributed way, and can be manipulated in similar way to the native distributed collection in Spark. So that we call the RDD. Yeah, and data frame keeps track of their scheme. Yes, because they need support various relational operation that lead to more optimized execution. Yeah, and the interesting is can be constructed. Yeah, from table in the system catalog. Yeah, for example, if we have a data source from the external parties, and maybe and also using the RDD of native Java, Python, and etc. So we can construct it based on these two kind of source, yeah, from the table or from existing RDDS. And then when we have this one, actually in DataFrame API, we can manipulate with various relational operation. For example, we want to grab into where or group by, or similar to DataFrame in R or Python. So if you're familiar with Python, we can use this also. And then we can view as an RDD on row objects, yeah, because it is allowing user to call procedure, yeah, Spark API, and then yeah, each object represents a logical plan to compute a dataset. No execution occurs until the user call a special output operations. Yeah, so we need to have this operation to execute or to come up with the result. So this is the example of the data API examples. Yeah. So we call the new have context in here, and then we will give the table user type of users, for example, and then we have a group. Yeah. So that's why in here we can manipulate with various relational operation that we can use like some key in here, and then we can state the count as the operation output in here. So if we state this is like initial context to read from Hive database. So if you see this one, actually Spark SQL have capability to read in the database sources of the big data like Hive, HBase, and another type of data sources. In this case, yeah, we using the Hive context because we connected with the Hive database, for example. And then in the user, we can get content, yeah, from table users, yeah. Of course, from the table content that exists in the Hive tables, yeah. And then we can group or we can filter that has some value in here. Yeah, for example, this one, the value is 21, which means we will have the user that under the 21, for example. And this is the count is open operation output operation, and Spark SQL build a physical plan to compute the final result, including the optimization. So this will be like the simple way how we work with it. So this is hopefully give you some idea or maybe like logical thinking when you have databases, for example, in Hive or HBase, and then you want to came out with your data using the Spark, and then let's see if the content in the database is limited. I think it not will be very time consuming for Spark to run it. But let's say if your table, for example, in here that the user table is in a million user of table, so you will see the difference. The operation speed performance will be very different. So that will be the important one. Yeah. So this is the data frame. So data frame will be explained as one of the component in the Spark SQL that that give us the facilities to framing the data and came out with the output operation in the Spark. Yeah. And then we also have the data model. The Spark SQL use a nested data model based on Hive. So because if we have using the Hive or maybe another databases, it will be data model will be based on the existing data model on Hive, and then support all major SQL data type, including Boolean, integer, decimal, string, date, timestamp, and also construct complex data types, yeah, like structs, arrays, maps, and union. And also we support our own definition on the data types, yeah. So it will be like very simple to understand about this data model, like in the database actually. And then for in the data frame operation, yeah, it's using a domain-specific language, call it DSL. Yeah, the domain-specific language is similar with the R or Python pandas. Yeah, if you're familiar with Python, I think it's not difficult to understand about it. And support all common relational operation from projection. It's just like select operation, filter. It's like where, join, join, merging something, yeah, and aggregation is for group by. And all text expression object in a limited DSL, domain specific language, yeah. Yeah, this is the data frame operation example, yeah. So for example, we have the employee as a data frame in here, yeah. And then we have a join, we do the operation, yeah, the operation join from department employee, we define the department ID based on the department ID. And then where we do the where for filtering, from employee that we select the gender is female, for example, and group by for for aggregate, yeah, aggregation using department ID and department name, and then we do the operation in the comment. So this will be in the declaration. Yeah, the employee is a data frame, and then employee department is the department ID column of employee. This equality test. Yeah, this is the equality aggregate function, and yeah, we have this. And after we have this one, yeah, all this operation built up an abstract syntax tree or EST of the expression. Yeah, will be passed to Catalyst for optimization. So from data frame, this is like a query data frame, and then we'll be optimizing, or we do the optimization into Catalyst. So this will be this process. After that one, we will have to the still in the data frame operation. Data frame can be registered as temporary tables in the system catalog queried using SQL. If you learn about database management system, you still remember about the concept of table view table is similar, I think, but different approach, yeah. And then sometimes convenient for computing multiple aggregate concisely, yeah, and also allow program to expose dataset through GDBC or DBC. So we here for communicate with the and compatibility with the another database will be handled by this component. And the data frame registered in the catalog still unmaterialized view, so that optimization can happen across SQL and the original data frame expression. So this will be our data frames, yeah. So based on this scenario, actually we can see that the data frame versus relational query language will be in several have some advantages, yeah. The first, data frame provide the same operation as relational query language. So I think there is no a lot of different, but just logical thinking about the data operation, yeah. Especially when we're using the SQL or environment in the PIC, I think you can see same things. And then this is easier integrated with full programming language, yeah. User can break up their code into Scala, Java, and Python. So I still remember I have one of my students, maybe about 2 or 3 years ago. We do the bachelor thesis in this one, yeah, using the Scala, but doing the in the Spark, yeah. So it's not using the Hadoop, but build the code in Scala and then work with the Spark. The benchmark is more efficient than Hadoop itself, yeah. So the benefit from optimization across the whole plan, when they run an output operation, and developers can use control structure. So the structure will be avoiding the looping, and maybe if we have a problem in another issue, yeah. So that's the main point of the data frames in Spark. If you have any question, please write in the chat. I will try to answer your questions. Yeah. Okay, I will stop for the first